Molecules and ions. In this video, we are going to learn some of the terms that we are using in chemistry, and in the end, we're going to learn the name of different ions. So, the first word that we are going to look at is the element, and we talked about this already in the chapter 1. So, if you remember, we were categorizing the matter by the properties, and we had pure substances that has elements and compound. Okay, so one thing you need to know that elements are not always individual atoms. In most cases it is, but it's not always. So it could be exist as individual atoms, or sometimes you will have molecules as the elements. So you have molecular elements. Okay, for example, chlorine, you never see Cl by itself. You always see Cl2. So it has two Cl connected together. So that's why it's called diatomic chlorine. So when we are talking about elemental chlorine, we are always talking about Cl2. Okay, so elements are exist as individual atoms, like noble gases. All of them are individual elements, individual atoms, and some of them exist as molecule. We have some other type of diatomic molecules as well, like oxygen, and some of them are like polyatomic, so like more than two elements are connected together, but still it's a molecule, but it's not like all the molecules are compounds. Okay, we talked about this in the first chapter. Some molecules, like diatomic molecules, are elemental molecule. Okay, some compounds. So we had two types of pure compound, right? Elements and compounds. Compounds are a group of some different types of atoms. Okay, they can exist as a molecular compound, and we talked a little bit about this in the previous video. They can be as a molecular compound, and that happens usually when we have two nonmetals connected together, or in some cases it could be ionic compounds. So what are these two? Again, molecular compounds are typically nonmetals bonded with nonmetals. Okay, so these two bonds together with a covalent bond, and they form a molecule. Okay, for ionic compound, typically we do not have a molecule, so it's not a molecule. Okay, so ionic compounds are typically metals bonded with nonmetals. Okay, so we form the ions, metals form cation, nonmetals form anion, and they form an ionic compound. So one thing that needs to be memorized is in ionic compound is not molecule. Okay, you do not have a molecule in ionic compounds. So if you remember this chart from the first chapter, when we were dividing the matter, so on the left side we have pure substance, and in chapter 1 we talked about element and compounds. Okay, so now we know that there are two types of elements. The element could be atomic element, or it could be a molecular element. Atomic elements are elements that has individual atoms together, like noble gases, as we said, like neon. So you have just single atom. Molecular elements are elements that have the same type of atoms bonding together. Usually most of them are diatomic, but we also have polyatomics. So here's another example as diatomic molecular element as oxygen, and I'm going to show you some more in the next slide. So on the right side of this diagram we see the compounds. As I said, compounds are a group of different type of atoms bonded together, and it forms a molecule or ionic compound. Okay, so if it's a molecule, usually it's between two nonmetals, like H2O, for example, water. Hydrogen is a nonmetal, oxygen is a nonmetal, so they form a molecule. So you see each of them have an individual unit of a molecule. So it's a compound, it's a molecular compound, okay? Ionic compound, as I said, remember in the last video I told you, we talked about these magnet balls. So when you throw them together, they just attract each other and form a cluster, okay? So that's what happens when you have a bunch of ions. So sodium chloride, table salt, so it's an ionic compound. We have sodium cation and chlorine anion. So they form this big cluster. So we do not have a molecule. So it's wrong to say NaCl molecule because it's not a molecule. But what we use is a formula unit. So NaCl is a formula unit of this big cluster of sodium and chloride. So usually in ionic compounds, we do not have one unit of molecule, but we have sodium, chlorine, sodium, chlorine, sodium, chlorine, and it will grow until very big size, with a size that you can see it with your own eyes. Okay, you can, if you really look at the table salt, you can see small cubes. So that's a cluster of millions and millions of atoms of sodium and chloride. So these are the diatomic molecules that we have to memorize. And diatomic, we say it has 2 atoms, right? Diatomic has 2 atoms. Okay? And there are 7 of them here. So we have 1 hydrogen, and then you start with the 7 and make a 7. It makes it easier to memorize, right? So these 7 molecules, these 7 elements forms diatomic molecule. We also have polyatomic molecules, like sulfur makes S8P4. So we have some elements that forms more than 2 atoms. It makes polyatomic, but they also form a molecular element. Again, about the ionic compound, they are not made up of molecule, okay? So what we are referring to when we say NaCl, it's a formula unit. So that's the formula unit for an ionic compound that we usually write as an ionic compound. So NaCl, for example, doesn't exist as discrete molecule of NaCl. It is a 3D structure so large that you can see it. As I said, the ions of sodium and chloride are next to each other, and they grow so big that you can see it as the small cubes of table salt. And the formula units used to describe the ionic compound, which are basically the empirical formula, and we learned about empirical formula in the last video. Okay, so polyatomic ions. So this is a table that nobody likes it, but still you have to memorize it. What is polyatomic ion? Ions that, let's write it, ions consisting of 2 or more atoms. Okay, so they are ions, so they have a charge, and they consist of 2 or more. For example, ammonium here, it has 1 nitrogen and 4 hydrogens, so it's ammonium. So we have ammonium with 1 nitrogen and 4 hydrogens, and the whole molecule has a plus charge. Okay, so it's not like we have a plus charge on nitrogen or plus charge on hydrogen, but the charge is on the whole molecule. Or cyanide, for example. Well, you don't know this, but it just looks like this. So you have a negative charge, and that represents the whole atoms. Okay, it's on a whole molecule. So that's polyatomic ion. So you have to memorize these ions, and what you need to memorize. Well, I cannot erase this part. Yeah. Well, what you need to memorize from this table is the name, so name, formula, and the charge. So what do I mean? For example, if you hear nitrate, you have to know nitrate, the formula is NO3. You have to know the charge is -1, and you have to know the name, it's nitrate. Okay, so if you hear the name, you have to know the formula and the charge. If you see the formula, you have to know the names, okay, and you have to know the charge. Okay, so these are the three things that you have to memorize from this table. For example, if you see something, if you see this, okay, you have to know that it's sodium and this is nitrate. You have to know the name, it's nitrate, and you have to know the nitrate charge is -1. Okay, so these are the three things that you have to memorize from this table. Even though there are lots of memorization in this table, but there are some things that might help you to memorize it. So you see some of them are just like each other. Like this one, it has just one oxygen different. So what you need to memorize is the 3 is ending with 8, chlorate, ATE. So when you're adding one oxygen to it, it becomes perchlorate. So when you're losing one oxygen, the 8 becomes ITE. Okay, so it's chlorate become chloride, and losing one more oxygen makes it hypochlorite. So when you lose oxygen, if you know the rule, it makes it easier. For example, you have sulfide and sulfate. Sulfate has 4 oxygen, and when you lose one oxygen, it becomes sulfite. You have the same example in nitrate and nitrite. Nitrate is NO3, nitrite is NO2. Well, some of them you have to memorize anyway. It's like hydroxide, for example, like ammonium is just one. But these things help you to memorize some of them. The other thing you need to know is when we are adding hydrogen and H+. For example, look at a sulfate. We have sulfate as SO4 2-, then we add an H+. So when you're adding H+, the charge also become 1-, and then you have HSO4. Okay, so when you add H, you can simply say hydrogen sulfate. So it was sulfate, you just add the hydrogen, or you can say bisulfate. So whenever you add the hydrogen, you can simply say hydrogen and the name of the ion, or you can say bi that ion, bisulfate, bisulfites. We had some other example, bicarbonates. So again, I know there is lots of memorization in this part, but this is a simple rule. So when you have chlorate, you have ATE, you have 3 oxygen, you lose 1 oxygen, it's minus oxygen. So the I8 become ITE, and if you're adding 1 oxygen, so it's plus oxygen, it becomes perchlorate, and losing 1 more oxygen in here, adding the hypo in the beginning, so it's hypochlorite. Hypochlorite, chlorite O2, chlorate O3, perchlorate O4. And when you're adding H+ here on any of them, you have carbonate CO3, and you add H+, it has 2-, it becomes 1-, it's HCO3, and it's either hydrogen carbonate or bicarbonate. So that was it for this video. There's going to be more examples on the Achieve, so you can practice this, try to memorize it, and you're going to use it in the exam 1.